Israel has always been very keen to develop renewable energy sources because it has no oil reserves of its own. That's why, dotted throughout Israel, you'll find dozens of wind farms, usually perched at the top of hills, like this one near Haifa. But there's an obvious problem with wind farms. If there's no breeze, like today, then the blades won't turn. What would be nice is a totally manageable breeze, a wind you can rely on, independent from the daily quirks of the weather. Well, in the 1970s, a maverick American engineer came up with a concept to do just that in the dry, hot air of the desert. And the idea is simplicity itself. Well, let me show you. You build a hollow tower, open at the top, and you pump up water to the top of the tower and spray it down the middle. Well, what happens next relies on two principles of physics. First of all, as water evaporates, it cools everything around it, just like sweat on the skin. And secondly, we all know that hot air rises. Well, the converse is true, cold air sinks. So, as the water evaporates, it cools the air up here, which begins to sink down the tower, gathering speed as it goes. At the base, the downdraft of air rushes through a ring of turbines. Electricity is produced, more than enough to pump the water up the tower. It's the perfect green power, no smog, no waste. Theoretically, it should be a breeze. In fact, the idea was so brilliant that the inevitable happened. Nobody took a blind bit of notice. Well now, after 20 years in the wilderness, a group of Israeli scientists have seized upon the concept. This is Technion, an entire city devoted to science, technology and pioneering research. Since the late 1980s, a group of researchers here have been applying their brains to making the concept of a power tower feasible. The equations all add up, but what would happen in the real world? Well, the first step was to build a benchtop model. Instead of water, this Perspex tower uses dry ice, but the principle remains the same. As the cool air drops, it falls faster and faster. This wind drives a turbine, and a turbine produces electricity. The next step was to scale it up. They built a tower a little bigger, 20 meters high. Well, now for the first time they can investigate the practical problems of water in a real tower. Here they're doing an experiment on the nozzle to get the water droplets the ideal size, 1/5 of a millimeter in diameter. Any larger and they don't evaporate quickly enough. The greater the evaporation, the greater the cooling, and that leads to more electricity being generated. Well, I have to say, all this looks and feels very impressive. But you know, there is a catch. Even with the tower 20 meters high, the downdraft of air is still quite weak. It's actually falling at about 4 kilometers an hour, which is hardly enough to power a small torch. Now, at this point, most people would have thrown in the towel. The thing is, you need to build a tower 100 meters high before it's even self-sustaining, where it would generate just enough electricity to pump the water to the top. Build higher than that, and only then do you get into profit. So how high do they want to build it? 1,000 meters, 1 kilometer high. And they reckon that 10 of these giant power towers could produce enough electricity for the whole of Israel. Building a structure 1 kilometer high isn't exactly easy, but the scientists at Technion have taken it seriously enough to put the design of the tower out to tender to 2 American companies. However, before they build the full-scale power station, they first plan to construct a pilot tower, a mere 200 meters high. The cost of this demonstration plant, $30 million, and they're trying to convince the Minister of Energy to supply most of the money.
It sounds like science fiction. I cannot tell whether it is going to work or not. So we decided to form a team of the best scientists to study the theory, to present to us a report, and if the report is going to be positive, then probably we will have a demonstration plant on a certain scale to see if it works, and not only in theory.
Even if the pilot plant is a success, there are still the technological problems of scaling it up even further to overcome, and of course the huge costs involved. It's certainly ambitious, and here is a sneak preview of what the scientists at Technion hope to see by the year 2020. A row of kilometre-high towers along the Dead Sea, churning out power for the whole of Israel. If they can do it, it'll be the cheapest, cleanest fuel ever. We'll just have to wait 25 years to find out. Watch this space.